Welcome back to Pocket Rock. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, we're going to be doing scientific notation. Scientific notation is a way to write large numbers or really small numbers in a condensed form. Here's how you do scientific notation. With scientific notation, the decimal is always going to go after your first digit. Always, always. So in scientific notation, this is going to be written 4.25 times 10 to the something. And to figure out what your exponent is, wherever you put your decimal, now you count to the end of the number. So here's where my decimal is going to be. So I count 1, 2, 3, 4, 5 places. Here's where the decimal originally started. Any number, there's a decimal after any number at the end of it, if it doesn't already have a decimal, if it's a whole number. So kind of like the whole number 12. The decimal is at the end, 12.0. That's the same thing as 12, okay? So, and we counted to the right. Right is always the positive direction. So large numbers will have positive exponents. So my exponent will be 1, 2, 3, 4, 5. So that will be 4.25 times 10 to the 5th. That's how you write 425,000 into scientific notation. And that was 3B4. Now let's look at 3B2. Decimals will have negative exponents. Alright? So you put your decimal after your first digit. 1 is my first digit, my first whole number other than 0. So in scientific notation, this would be 1.0, or you can just write 1 times 10 to the something, and my exponent will be negative since it's a decimal because I'm counting to the left to go back to the original place of the decimal. Left on a XY graph is negative. So that's how you can remember that. So your exponent would be 1, 2, 3, 4, 5, 6, 7 places. So that would be 10 to the negative 7. So to write this in scientific notation, 1.0 times 10 to the negative 7. Alright, now let's look at 3E6. They are wanting you to calculate these by scientific notation. Yes, you could go put in 160,000 times 0.0000, however many zeros, 53, and do your calculator. Yes. But we're going to do it by scientific notation. So turn this into scientific notation. Always put your decimal after your first whole number. And then you can count over for times 10 to the what? 1, 2, 3, 4, 5. You're always going to count to the end of the number because this is where your decimal is to start with. Put your decimal here and you count to where your decimal originally was. So this would be 1.6 times 10 to the, what do we say, 1, 2, 3, 4, 5, times 10 to the 5th, times, now let's put this into scientific notation. Our decimal is originally here, but we want it to be after our first digit. So we're counting back to the original decimal place and we're going to the left, so that means it's a negative. Decimal is always going to be a negative exponent. 1, 2, 3, 4, 5, 6, 7. That's 7 places. So this would be 5.3 times 10 to the negative 7. Okay? Everything is multiplied. This means 1.6 times 10 to the 5th times 5.3 times 10 to the negative 7. When you're multiplying everything, multiplication is commutative, so it means we can move things around the operation sign and it will not change the answer. So therefore, I'm going to put my numbers together. 1.6 times 5.3 times 10 to the 5th times 10 to the negative 7. Now you can do the 1.6 times 5.3 in your calculator. So 1.6 times 5.3 is 8.48, and then we are multiplying our same bases. We have the same base and we're multiplying, so you add your exponents. 5 adding a negative 7 still leaves a negative 2. When you get to this point, make sure your decimal is after the first digit. You always want your decimal. Your final answer should be your decimal is after your first digit. And so this is your final answer for that one. now let's look at 3D7. The problem we did before was multiplying numbers using scientific notation. Now we're going to be dividing numbers using scientific notation. Alright, so first off we need to put this into scientific notation. It's a decimal, so it means it's going to have a negative exponent. My original decimal place is here, but I want my decimal after the first whole number that's not a 0. So counting back 1, 2, 3, 4, 5, 6, 7, 8 places. So my number in scientific notation would be 1.4 times 10 to the negative 8. And that's all divided by, putting this one in scientific notation, my decimal goes after the first number. Counting back 1, 2, 3, 4, 5. So that would be 3.9 times 10 to the negative 5th. Okay, we're dividing. So instead of writing it horizontal like this, I'm actually going to write it a division like this. Okay, because now I can see I am now going to divide these numbers. 1.4 divided by 3.9. I can do that in my calculator. So 1.4 divided by 3.9. I'm just going to round to 2 decimal places, or that would be 0.36 times 10 to the, and I rounded, it was like 0.35897. So 0.36 times 10 to the what? Since I am dividing, when you have the same base, what do you do to your exponents when you divide? You subtract. So this is negative 8 minus a negative 5. Okay, I'm going to write it out. Negative 8 minus a negative 5. Keep up with your negatives. What do you do when you minus a negative? You are now adding. So this becomes negative 8 plus 5, which would be negative 3. So keep up with your signs. That is not your final answer. Do you see how my decimal is not after the first whole number? My decimal needs to be after the first digit. So I put my decimal where I want it to be. I went to the left one place to get back to my original place. So since I went to the left to get back to my original place, left is negative, and I went one place, which means I have to subtract 1 from this exponent. Left means you subtract. If you go to the right, it means you add. It's a positive. So my final answer, because you want your decimal after the first digit, that's considered standard form for scientific notation. So my final answer would be 3.6 times 10 to the, I'm in debt 3, I'm in debt 1 more, that would be a negative 4. So that would be your final answer.